P-value. Let's look at an example to understand p-value. The historical scores of students in all subjects are taken together and averaged at 900 with a standard deviation of 180. The university felt that this year's performance has improved. Suppose the scores of 200 students chosen at random are noted, and if the average of them is 935. Determine the minimum level of significance at which null hypothesis will be rejected. Assume that scores follow a normal distribution and that the standard deviation has not changed. The solution will be: let x denote the random variable indicating the score of a student this year. X follows a normal distribution with mu and sigma of 180. Let x bar denote the average score of 200 students chosen at random. X bar follows a normal distribution with mu and standard deviation being 12.7279. Sigma by square root n equals 180 by square root 200 equals 12.7279. The historical average mu naught will be 900. Null hypothesis: the performance during this year remains unchanged. The historical average mu naught holds 900. Standard deviation equals 180. Alternative hypothesis: the performance has improved this year. Mean is greater than historical average and standard deviation. Mu is greater than mu naught, sigma equals 180. Level of significance, alpha. Decision rule: reject null hypothesis if x bar is greater than c, where c is chosen so that prob value of x bar is greater than c when null hypothesis is true equals alpha. That is prob value, z is greater than c minus 900 by 12.7279 equals alpha. Setting c equals 935, c minus 900 by 12.7279 is equal to 2.7499. Prob value of z is greater than 2.7499 equals 0.002981. Therefore, for alpha is greater than 0.002981, you reject the null hypothesis. Decision rule: reject null hypothesis if mean is greater than c, where c is average scores of chosen students, and that is prob value will be greater than z when c is average scores of chosen students being 935. Then the p-value of the test for the given value of x bar is 0.002981. P-values will vary for different values of x bar. The p-value is an indicator of the ease with which you can reject the null hypothesis. When the p-value is low, for example 0.002%, you can easily reject null hypothesis. In contrast, if the p-value is very high, it is rather difficult to reject the null hypothesis.